So this is a better way. We just identify each data and do simple random sampling from each data. That is a good way. But unfortunately, we can't apply any of these out here. What are we going to do? We are going to go to our OPD. First, we have a research question, right? So we are going to find the target population, the target sample, and then we are going to go to OPD and take every sample possible, every people out there. So here, the samples that we are going to get are going to be biased. We know that.
Okay.
But we have no other way.
Can
This
I
kind of
start?
sampling is called convenience.
Okay, fine. So this is R.N. Mondal, Assistant Professor, Department of Community Medicines. Okay. Yes, please.
Understood.
So today I will discuss about the concept about the
Per day, like you will be allotted 6 days. On 5
concept
days.
about three
You're going to
things.
go to the OPD for 6
Number
days,
one,
10,000
family,
and take every patient.
social problem,
Understood?
and SES.
So there we are not
This is
applying
means
any of these.
socioeconomic
We are just
status.
doing it on
Because
our convenience, so it's called convenience.
Very shortly,
Understood.
you will be going to visit
Now tell me.
a family
100
or
people we have with the
family
population, 100 people we
care
have with the
program.
sample.
They are
If I reduce the sample
different
size to 10,
components. So one of the components is
it will be much easier for us.
socioeconomic status. Once you will be
It will be
visiting
much
a
easier for us.
family, you should know what
But
a
the
family
results
is.
we are going to get
Okay.
are going to be
So
best.
let's start about what a
The more
family
people in the
is.
sample, the better. But if I like increase this to like 1,000 or 10,000,
Perhaps
the results going to be good. But this
Everybody
one is very tedious. And if I keep on increasing at some point of the
a
time,
rough
it's going to be-
idea
Correct.
about the
We can
family
do that.
because
So what is
all
the
of
optimal
you
sample size?
had brought up in a family.
Understand these things. These are going to help really too much in like third year.
Okay.
Understand these optimal sample size. The sample size which is like gives the best outcomes on the least amount of effort and cost and everything. Right? Like sampling involves money, time, effort. So the optimal the less the better. So the optimal sample size gives the optimal size or optimal number of people which we are going to take. So that the results are going to be more or less unbiased, and our like cost is minimum, our time is efforts are minimum. Okay. Now here is equal to this is a formula. Say if the population size is 1 lakh. Now we are drawing inference from this to this, so there is going to be error. We are going to allow a bit of error because we can never make it error free. We can allow a little bit of error. So say we are allowing 5% error. So what is 5% in the terms of proportions? Calculate it. Yeah, calculate this. Calculate n. Calculate this. In a second, you just calculate. Okay. Correct. That is the number of people which we are going to take, so that our error is minimum and our cost is minimum. But when is this formula applicable? When we know this thing. When the population size is known. Whenever it is not known, what are we going to do? We are going to use this formula. This formula. What is this? This Z E square is a constant. We are going to take it as 1.96. Okay. E is, I told you once again, 0.05. Variance is the variance of the sample which you have got. Okay. Say the variance comes out to be 2. So let's compute this. Say, where is this on this? That is the optimal sample size. Whenever we don't know, I'll write it down here. For known population size, and for here for unknown population size. I'll also write the name of this formula. This is given by two scientists called Taro and Yamane. This one. Okay, understood. So we are going to use this formula only because we have every idea about our OPD. We know how many patients come and go every day, right? So we are going to know this. This is known, and then we are going to use it to calculate this. It will roughly come out to be something around 100, 120, 150, nothing more than that. That is what it has been. So we are going to do that. Now we have taken the data. What are the first things we are going to do? Identify the data. So let's classify data. Let's classify data. Data is of two types, qualitative and quantitative. Don't get mixed up with the research qualitative and quantitative, but these are different things. What is qualitative data? Say I ask you guys, what are your grades in your previous exam? You are gonna say A, B, C, D or something like that. You are not gonna say 1, 2, 3, 4 or anything, right? So here it's a data, but it is no number. It only has a quality, right? That kind of data is called qualitative data. Understood? And if I ask you guys your heights or weights, that's gonna be a number. Quantitative data. Now quantitative data is of two types, discrete and continuous. What are these? Say I ask you your family strengths, like how many people you have in your family. Okay? How much it's gonna be? 4.6, 4.6, 3.2. So the data which can take any specific numbers only, not anything, are called discrete data. Understood? And which can take any type of numbers is called continuous data. Understood? Understood? Now qualitative data. It has two categories, nominal and ordinal. So what is ordinal data? First, I go to your class and ask everyone about their grades. The number of people who got A are say like 20, B are say like 30, C are say like 30 and so on. Okay? I take the number and so on. If I like mess it up, I write it like this. Are these two data same? Is this even making sense? I think this is not even making sense. Like, why will you write D after A and all? Understood? So there is a sense of ordering among the categories. When there exists something like this, we are gonna call it an ordinal data. But if I ask your religion, say X religion has 30 people out here, Y religion has 80 people out here, Z religion has 28 people out here. If I write it like this, it won't make any difference because there is no sense of ordering in these categories. This kind of data is called nominal data. Understood? Everyone? So we are going to identify the data first. Now we know how to identify data. Now, what are we going to do? We are going to do some frequency distributions. We know what frequency distributions are. We have done these in class, in school, right? But yes, I'm going to explain once. Two types of frequency distribution we have. One is grouped, and is ungrouped. What is ungrouped? Say, I ask for people, like how much you guys have got marks in your previous exams. Some people say 5, some out of 50, some people say 10, some people say 7, some people say 8, some people say 9, and so on till 50. So 2 people say 5, 3 people say 7, and so on. Okay. Here, what are we measuring? 3 people have got 7, right? So 3 is the frequency. This is a frequency distribution. But here we are having frequencies corresponding to single points. These are called ungrouped type frequency. Okay. Understood? And say we don't like to write it like this. We want to write it like this. This kind of frequency distribution is called group. What is the key difference? Say, if I have written the marks descriptively, it would have been gone in like this for 2 5s, 3 7s, say 2 8s, and so on, like this. So if you try to find the mean, say average, we are trying to find the average. What are we going to do? We are going to add all of these. Correct? But this is not making sense adding 5 twice. We can just write 2 into 5. Okay. So basically what are we doing? We are just multiplying these and this and taking the sum. And what are we dividing this by? 2 plus 3 plus 2 plus so on, like the frequencies. So the formula will, average will turn out to be summation xi into fi divided by summation fi. Understood this much? Visible to everyone? দেখতে পাচ্ছিস কি করে? এই দিকটায় এখানটায় ঢুকে যা। এদিকে সেটাই তো আমি জিজ্ঞেস করছি, বুঝতে পারছি না বোর্ডটা নেই কেন, সবাই শুধু পিপিটি পড়াবে। এইদিকে হ্যাঁ লিসেন নেই, দেখলাম তো আমরা কিচ্ছু নেই, দেয়াল আছে। Now, in this case, we don't have any single corresponding numbers. What are we going to do? We are just going to take the middle value of this 7.5 and then multiply it with 30. Okay, and then find the average. That is how we do it. Correct? Now tell me one thing. For a qualitative data, which is also called categorical data, I'll write it down. Why categorical? Because it has categories only. It doesn't have any number, just categories. Why is this quantitative? Because it has numbers. You can add these two. Like if I want to find out the sum of the scores of these two people, we can just add. Right? If you want to find the difference, how good this guy has done above this, we can just subtract. But here we can't do anything. We just have categories. Correct? So here also we are going to treat it like an ungrouped frequency distribution. But we cannot find the mean, but the diagrammatic representations will be the same. Understood? And for group data, group distribution, the diagrams will be different. Now let me explain the diagrams first. These are going to be necessary. You're going to be doing this in your projects. Like first, pie chart. Everyone knows what a pie chart is. How does it look like? And has sectors in it. It has sectors like this. Okay. How is this angle determined? What? Theta is equal to proportion, not percentage, proportion into 360 degree. Correct. Say there are 5 of these people in a total of 100. Okay. So the proportion is this 5, say 10. 5 by 10 into 360, 180 degree. Understood? This is how it's done. But these are basic things. What I want to tell you is, when is this chart applicable? And I will show you another thing, it's bar diagram. Bar diagram is also the same. What are we doing? We are just plotting the frequencies out here, corresponding to various groups. Say A, we have this, B, we have this, and C, we have this. See bar diagram. How many are there? We think there are 5. D we have this and E we have this. This is a bar diagram. When are we going to use this and when are we going to use this? This proportion is like made from the frequencies only. These are frequencies only, right? But when are we going to use this and when are we going to use this? Tell me. Apply yourselves. Let me. When in case of nominal data, there is no ordering. We are going to use the bar diagram. Tell me why? Because you don't have a sense of ordering. Correct? Like if we draw X here, Y here, Z here, it's okay. We don't even have to know which is the starting point and ending point. We are just plotting. But when there is a sense of ordering, we can show it like this, right? So for ordinal data, we are going to use bar diagram. Understood? And for ungrouped frequency distribution, we are also going to use bar diagram because obviously 5, 7, 8, these are going in an increasing order. So this is also ordering. There is a sense of ordering order. So here also we are going to use bar diagram. Understood, everyone? When to use what? That is important. Everyone knows how to draw these. Now the next diagram, histogram. What is histogram? Looks like a bar diagram only, just doesn't have the gaps. Looks like this. Correct? This is how a histogram looks. It's like this only. Why does it not have gap? Because the intervals are plotted here. Say 5 is here, say 10 is here, 15 is here, 20 is here, and so on. Understood? The intervals are here. So there are no gaps. There shouldn't be any gaps. But let me show you something. Let's plot this data, okay? 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, and the last 50. Done. So 5 to 10, what are we plotting? 30. Say here. Okay. 10 to 15, what are we plotting? 20. Here. 15 to 35, what are we plotting? 20. Okay. 35 to 50, what are we plotting? 30. Okay. Now tell me one thing. 30 people here are concentrated in these 5 points only. Okay. Like 30 people are here. Also at the same time 30 people are here. But are these proportional? Are the figures proportional? No. But everyone knew till now, even in the book, like Kale Park also it's written, I don't know why, that people plot our frequencies on the y-axis. It's not the case. We plot frequency density. What is frequency density? 30 divided by the class width, which is 10 minus 5, and which is 6. Understood? So we are going to plot 6 out here. Okay, say this is 6. What are we going to plot here? Divided by 5. We are going to plot 4 out here. What are we going to plot? 20 divided by how much? 20. 1. We are going to plot 1. We are going to plot something like this out here. Understood? Now the data will be proportional. Understood how to draw a histogram? Everyone understood? Now going on to like the actual analysis is for quantitative data. Central tendency. What is central tendency? We are finding a representative value, a middle value. Okay. So what are the 3 ways? One is mean, one is median, and another is mode. Everyone knows what these are, but let me explain now. What is mode? Mode is the value which occurs the maximum number of times. Okay. So if we want to like direct our analysis in that way, then we are going to find mode. Okay. What is the mean? The magnitudinal center. We add all the values and we divide by the total number of values. Okay. And what is the median? A middlemost value. We have what are when we arrange the data in ascending order, the value in the middle. Okay. Like the value below which 50% of the data lie and above which the 50% of the data lie. Now, when are we going to use the median? We have the mean. Why do we need the median? Tell me. Can anyone explain? Why do we need the median? We had mean already, right? We had mean in the very beginning. Mean. Why are we needing the median? Let me explain. Say we have a data 2, 3, 5, 7, 8, 10, 200 plus. Okay. What will be the mean? Find the mean. 10, 10, 5, 10, 10, 5, 25, 35, 235 divided by 1, 2, 3, 4, 5, 6, 7 যা আছে তাই কত আছে 3 55 হ্যাঁ 33 পয়েন্ট সামথিং আসবে তো তাই হবে 2 কেন আসবে এখানে তো 25 আসছে ঠিক আছে something like this will come. Is most of the data even close to this value, right? So why is this happening? Because this is a very big value, right? These kind of values are called outliers or extreme values. Same might have happened if we had got something like this 2, 50, 52, 57, 58, 63 and 70. Same, the average would have come a long way down, where the average should have been somewhere near this. Now find the median. Find the median. Find the median here. 1, 2, 3, 1, 2, 3. This is the median. Quite representative. Quite representative. Not getting affected too much by outliers, right? If we start increasing the number of outliers, then this will also shift to this side. So the median is foolproof out here. So when are we using median? In case of outliers, when there are outliers or extreme values. Everyone understood? Another case. Say for these things, we can find the mean. What are we doing? We are just finding the middlemost value and multiplying it with the frequency. Like here 12.5 into 20. Here say how much? 25, 20. How much? 42.5, 30. Multiply all this and find the mean, right? We know this. But what are we going to do if we had value like data like this? 50 to 5 to 10, 10 to 20, 20 and above. 30, 20, 30. Find the mean if possible. Can you find the mean? Who told you? Who told you there is no value for like 32? There can be 5 values like 32, 37, 41 and like that. There can be 5 values, outliers. There can be. Not possible. Here, median is the only way. Understood? Now, how to find the median? Formula for median. Say, we are just given only the data, no frequencies. So, what are we going to do? 2, 5, 7, 8, 9. Okay. How many data? 5. So, how do we find the median? N plus 1 by 2, th term. What is n? 5 plus 1 by 2th term, which is third term, right? 6 by 2. Median. Say we have 10. What are we going to do? Here, n by 2 is possible, but that will go this. N plus 1 by 2 is n by 2 plus 1 is possible. Yes, we get this, And what are we going to do? We are going to take the average of. Understood, everyone? So this is how we find the median for just normal data, not frequency data. Say we have 3 2s, 2 5s, 4 7s, 2 8s, 3 9s, and 1 10. Here also what we can do, we can just do all of this. Else, we can arrange it as a frequency distribution. Ungroup frequency distribution. Now we find the cumulative frequencies. What is cumulative frequency? There are 3 people who are less than or equal to 2. Like 3 people who are equal to 2, but they can be labeled as less than or equal to. There are 2 people who are equal to 5. Okay? And 3 people who are less than 5. So 2 plus 3, there are 5 people who are less than or equal to 5. Okay? There are 9 people who are less than or equal to 7. 11, 14, 15. Understood? Correct? Understandable? So we divide this by 2. What is 7.5? The first cumulative frequency to cross 7.5 will be the median. Who crossed it? 9. This, what is it corresponding to? 7. So 7, count. For 15, what would have been the median? 16 by 2 is equal to 8th term. Count 8th term. 1, 2, 3, 4, 5, 6, 7, 8. Understood? How we do it? Understood the process? For group data, you don't have that much, but I'll just tell you the formula. You don't have to do it in your hand. But till now, I'll recommend you to understand it now and keep it in touch, because in 3rd year, it's going to be easier for you. If you keep on forgetting these things, it's going to be a big task at that point. Understood? Just understand it. You don't have to give in much effort, but keep it in mind. Okay. Say 5 to 10. 10 to 20. 20 and above. Like this. 20, 30, 20. Let's find the cumulative frequencies. 20, 50, 90. What is n by 2? 45. Which class crosses it? This one. First crossing it. So the median is somewhere inside this. Understood? Now just the formula and nothing else. The formula is this. L0 plus n by 2 minus Fp. This is the formula. Just know this. You will not use it ever. At least in your MBBS. In your MD, you are going to use it very frequently. It's going to be very important at that point. But just know at this point. L0, lower class boundary of median class. The median class is this. So the lower class boundary of the median class, which is this. Me class I am writing. 10. N by 2, just figured out. Fp, the cumulative frequency of the previous class. 20. FAB, frequency of the median class. 30. C, class with 10 minus this. What is that? 10. I'll just write it. Okay, that's it. You just know the formula. You don't have to use it at this point. Till now, just keep it very good. The concept is really clear. Now you know all of it. Acha. Now tell me one thing. Tell me how these two are different. And none. Another one. Wait. How are these three data points different? The average. That's a different thing. Like we just have this data. We are not analyzing the nature of these. We're just analyzing. We have the data and we are just like finding the mean, median. We are describing the data. So how are these different? Check the find the average. All of their will have the average 6. X bar is equal to 6. Okay. Check out the median. All of their medians will be 6. Understood? So how are we going to differentiate this? By analyzing the gaps, the intervals. Understood? These are going to be different. Measuring these is a topic called measures of dispersion. Tomorrow we are. I'm going to teach till now this part now today, and tomorrow we are going to talk about this. Today this part will be completed. Okay. Measures of dispersion. I think you guys had a class. Coel took a class of you guys, right? On the 12th, or you guys just came and gave attendance. Attendance is okay, that's one. She's also statistician. That's why I'm thinking whether you guys have already done this or not. But okay, measures of dispersion here. What is the first measure of dispersion? Range. 10, that is highest minus lowest. What is highest? 10. What is lowest? 2. 8. Here also 8. 8. But here 9, not 10. So here we find out a way to differentiate these. Another way. Standard deviation and variance. What is standard deviation? We know the formula 1 by n summation xi minus x bar whole square square root. This much we know. I have no idea why in Park also a different type of formula is written. It's written like this: 1 by n minus 1 summation xi minus x bar square when n less than 30. This is completely wrong. There is no formula like this. It is written in the book, but it is wrong. It is never right. Okay. This is the only formula of standard deviation we have. Okay. This is the only formula of standard deviation. So see, let's see what happens here. 2 minus 6. How much is it? Minus 4. 4 minus 6. How much is it? Minus 2. 6 minus 6. 0. 8 minus 6. 2. 10 minus 6. 4. We could have just added this up. These are the differences only, right? We could have just added this up. But see, if you add this up, it will 0 every time. So that is why we need to get rid of these minuses, and so we just square them. What is the square? 16. 4, 0, 4, 16. Now what do? We take the sum and divided it by the total number of values. There are 5. We have variance 8. So what are we doing? We are taking the average of these square deviations, right? So what are we doing? Mean square deviation और आगे हलो root. Now let's get from the back. Deviation. What are we doing? We are taking the differences, deviations, right? Square. We are taking the square. We are taking the mean. We are doing the average, and then we are doing the root. Understood? So standard deviation is also called root mean square deviation. Understood, everyone? I missed. So till now, understood everyone? Now let me tell you one thing. Units. This is not like, okay, I could have told this later also, but I want you guys to be sound. And that is, say we have the units as, these are the, okay, I'll give a separate example. We have got some babies, these are their weights, okay, in kilos, not newborns, some babies, okay, these are their weights in kilograms, okay. What will their average be? 6 kilograms. Okay, it will never be 6. I have seen most of you write 6 and just go back in the exams. It should be 6 kilograms. Okay, the median should be 6 kilograms. The rate should be 8 kilograms. The SD should be root over of 8. It is something a little less than 9, like 2.78, something like that. 2.828. root 2 তো হলো 1.414, তাহলে root 8 তাই হবে 2.828 হবে, তাই তো 2.828, okay, kilograms. Understood? If you are not writing kilograms, I am deducting marks, okay, and the university will also deduct marks. It's okay. Everyone understood till now? What else? Units a little bit. Units থেকে another kind of dispersion, the last one, that is coefficient of variation. Okay, coefficient of variation. What is that? SD divided by x bar into 100%. দেখতে পাচ্ছিস? তাই ভাবে অনেকক্ষণ পর রিলাইজ করে ওখানেও ওটা বসে যাচ্ছে। SD divided by x bar into 100%. Correct? Here SD will have a unit, x bar will have a unit, will get cancelled out, so no unit. So coefficient of variation is a unit free measure of dispersion. Da bola bola. The only unit free measure of dispersion is coefficient of variation. Understood? Why is coefficient of variation necessary? Say we want to compare two data points, compare two data sets. Okay? So we say have weights of kids, one has this, and one has say this. One in pounds, one in kilos. What can we do? We can convert this, or else we can just directly compute this, as the units will get cancelled out anyways. Understood? We can just compute the CV for this and the CV for this, and the units will get cancelled out. Okay? Understood? And another thing, the more the x bar, usually it's better. Like say we are measuring the number of scores a batsman made. Independent example, it's not a medical example, but okay, this is what I came up with at this point. Say a number of scores a batsman did in every overs, lead 6 overs, say 3, 10, 20, 5, 15, 30, 0. Okay. Another batsman did something like this, 20, 22, 24, 0, 21, 20. See, here the data points are less scattered, here the data points are more scattered. The average might be the same. So, here for this case, the SD would be less, right? This is a better batsman. Okay. If this average would have been more, or this average would have been more, this is not the average here would have been more, then also their batsman would have been good. So the more average out here, the less SD will result in a lower CV. A lower CV will indicate a better and a consistent more data point. Understood? If getting a greater average, it corresponds to a better data. Understood? Understood everyone? And the last thing, that is skewness. Say the histogram. If we start increasing histogram, let's draw the histogram here only. So if we start increasing the intervals, it's gonna be more smoother, right? In the long run, it's gonna be like this. So this is called a frequency curve. So in a frequency curve, but if we draw a line from the mean, if both the sides are symmetric, like equidistant, then we call it a symmetric distribution. If it is seen like this, then it is left skewed. And if it looks like this, right skewed. Understood? Now what is the thing? For left skew, for symmetric, the mean will be equal to the median, will be equal to the mode for this, for symmetric. For left skewed, you can see the positional center, the median will be here. These values have less here. These values have less frequency. This is the tail is here. There is more values out here, right? I am trying to say is, say this extends on 0. Okay, 0 to say 100, we have this kind of frequency, and 100 to say like 120, we have this much. Okay, so what will happen? The mean will shift to this side. So if mean less than median, less than mode, then the distribution will be called left skew. Understood? Understandable. And to the reverse. And why do we read this here? So that we can understand the data just by seeing at it. We don't have to analyze. Understood? Understood, everyone? And the last thing, which is a bonus formula, just know it. It's necessary also, but just know it. At a bonus, it goes like this: mean minus median is equal to 3 into mean minus mode. Or I'll write it in words. Mean, I wrote it different. I wrote it into it. 3 into mean minus median is equal to mean minus mode. This is an empirical formula. Like, it just wants to say that this gap is thrice this gap. This gap is thrice this gap. Understood? This gap is thrice this gap. Understood?